The diagram shows a curve with equation this. A is the point 4, 0 and B is the point 0, 2. So these 2 points A and B are on the graph, on the curve. Find the equation of straight line that passes through A and B. Now we have to find the equation of this straight line which joins A and B in the shape of y is equal to mx plus c. So first we will find m. M is y2 minus y1 over x2 minus x1. So here this is x1, y1, x2, y2. Okay. So plug in the values. 2 minus 0 over 0 minus 4. It is 2 over minus 4, which is minus 1 over 2 or minus 0.5. So equation is y is equal to m. We got them. This is them, minus 0.5x plus c. Now to find c, we will put any point, either a or b, whichever you like, into this equation. So let me put this one. This one. You can put this as well. You will get the same answer. You will get the same c. So here x is 0 and y is 2. So 2 minus 0.5 into 0 plus c. So c will be this will become 0. This is 0. 0 into minus 0.5 is 0. So c is 2. So c is 2. Therefore equation of straight line is y is equal to mx plus c. M is minus 0.5x, 0.5 and then x plus c, and c is 2. So this is equation of the straight line AB. In the next part we have to show a square is 14 and b square is 4. And student, you should remember the concept, the idea, the key point, that any point which lies, which is on the graph, or we can say that if graph passes through any point, right now this graph, this curve pass through A and B. So the rule is that any point from which the graph passes can be put into its equation. So these points can be put into the equation, this one, because these points lies, they are on the graph. They are on the graph. So any point which is on the graph, that point can be put into its function or its equation. So because the reason is that any point which is on the graph, when we put into the equation, the equation will remain balanced. These points which are on the graph, those points do not disturb the balance of the equation. The equation remain balanced. And if you put any point which is not on the graph, which is away from the graph, maybe inside or outside, if you put that point, so in that case the equation will not be balanced. It means that if you put any point which is not on the graph into the equation, the left hand side and right hand side will not be equal in that case. But any point which is on the graph, right now it is A and B, so these points will not disturb the balance. So using this concept, we will plug these points one by one into this equation. I have written this rule over here. Any point that lies on graph can be put into its equation of graph. So these 2 points, A and B, these 2 points fall, they are on the graph. So I will put these one by one into this equation. So let's put A first. So x is 4. So here x is 4. So 4 square over a square, and y is 0. Y is 0. So 0 square over b square is equal to 1. So this will become 0. 0 over something is 0. So we have 416 over a square is equal to 1. By cross multiplication, a square is 16. So we have shown with the first result. Now plug in this value into the same function. So here x is 0, here x is 0. So 0 square over a square plus y is 2, 2 square over b square is equal to 1. So 0 over something is 0. So we have 4 over b square is equal to 1. By cross multiplication, b square is 4. So we have shown the result. Now in part B, the point P 2 comma K and the point Q are on the curve. So these 2 points are also on the curve. Look at here. They are on the graph. They are on the graph. So using the same concept, any point which is on the graph or on the curve can be put into its equation. This is the concept of coordinate geometry. So let me put these one by one. So let me put this first, P. So x is 2 and y is k. X is 2. So 2, it is 2 square over 16 plus k square over 4 is equal to 1. So it means it is 4 and 4 over 16, 1 by 4. You can check it from the calculator, and plus k square over 4 is equal to 1. So let me take LCM. You can bring this 1 over 4 on the other side and then do the simplification. Okay, so let me do here. So it is, let me bring this 1 over 4 on the other side. So k square over 16 is equal to 1 minus 1 over 4. So it will become 3 over 4. Now by cross multiplication, k square is equal to, this 16 will come over here, 3 over 4 into 16, and by calculator, 4 ones and 4 fours are, it is 12. K square is 12. Okay student, k square is 12. And if, now k square is 12. Let me show over here. I don't have space here. So k square is 12. And let me take square root on both sides. I think I did mistake here. It is k square and there is a 4 in the denominator. So I wrote 16 here, which is wrong. So it is 4 here. Okay. Okay, so it is 4. Let me correct the mistake. So I have corrected the mistake. It is k square over 4. I wrote here 16 mistakenly. So now k square over 4. So after cross multiplication, k square will be, this 4 will come over here, 3 over 4 into this 4. This cancel. So it is 3. So k square is 3. So take the square root on both sides. So it will be, k will be under root 3. Or you can take it the decimal value from the calculator. So it is 1.732. 1.732. 1.732. So you can use both of them, either this one or this one. So k is under root 3. I prefer this one, under root 3. The next part, it looks tricky, but actually it is not, because now we have found k. So just plug in the value of this under root 3 in this point. So this p point is over here. Its coordinates are 2, under root 3. And this point q, which is over here, its coordinates are 2, minus under root 3. And now we have to find angle POQ, which is POQ. And student, just write these coordinates over here and draw these lines so that you can see clearly which angle you have to find. And student, if you observe these coordinates, look at here, this is 2, under root 3. How we have found this p? So if you are here, so this distance is 2, and then this distance is under root 3, isn't it? So how did you find this coordinate? You move from this origin 2 steps on the right, which is 2, this is 2, and then you move under the length under root 3 on the top, and then you reached at point P, which is under root 3 over 8. So this is how we found the coordinate. This coordinate help us to tell that the distance from this O to this point is 2, and the distance from here to here is under root 3. And this is how we have found this coordinate P, 2, under root 3. And this has given us, and this is right angle triangle. Now we will find this angle, and this angle is, we use SOHCAHTOA. So using SOHCAHTOA, we use tangent. So this angle, let me call theta. So tangent theta is opposite over adjacent under root 3 over 2. So theta is tangent inverse under root 3. Under root 3 over 2. Okay, so let me use calculator. So it is tangent inverse under root 3 over 2. .89 degree. So this angle is 40.89, but we have to find this, and this angle is also 40.89 because these are symmetrical. So we will, to find this whole angle POQ, we just multiply this 2 with 2 by 40.89. So this will give me into 2. So 81.79. So it would be 81.79. So the answer is, final answer is 81.79 degree. This is the answer. It's a good question. Look tricky, but it is simple. In the C part, the area enclosed by the curve with equation this is pi AB. Okay, so find the area enclosed by this curve. Okay, so the area of this is given. The area of this is given. This is the area, and we have just put the value of A and B here. So area is pi. Give your answer in multiple of pi AB. And here A is, what is A here? It is A square. And we have to put A. So this A square is 16. A square is 16. And A is taking the square root on both sides. A is 4. So we will plug 4 here. 4. And B square is 4. B square is 4. So B is 2. So put B2 here. So it is 8 AB. The area is 8 AB. Using this equation. Sorry, it is not AB, it is pi. Sorry, the area is 8 pi. 8 pi. 4 to the 8, 8 pi. And in the second part of the C, a curve mathematically similar to the one in the diagram intersect the x-axis at 12,0 and minus 12,0. Okay. So this is the diagram of the last step, and there is another similar diagram. So let me draw that. That is a little bit bigger than this. This is another similar diagram where this coordinate is 12,0 and this coordinate is minus 12,0. Okay. So let me make this a little bit shorter so that you get the idea. They are similar. The size is different. The shape is same, but the size is different. Okay, students. So now work out the area enclosed by this curve. We have to find what is the area of this. Because these two are similar, so we use the concept of similarity. In that, area ratio is A1 over A2 is length 1 over length 2 whole square. Okay, because we have to find the area of this, so let me call A1 here, and area of the second one, the given, which is 8 pi, we have just found 8 pi is equal to, let me take the length of this. This length is 12. This length is 12. 0, 12 mean this is origin to this length up to here, it is 12. 12 over, and this length is 4 whole square. Okay, let me do simplification inside first. 4 1s and 4 3s, and 3 square is 9. It is 9 over 1. Okay, by cross multiplication, A1 is 8 pi into 9. So it is 72 pi. Should I put the value of pi? Work out the area enclosed by this curve, giving your answer as a multiple of pi. No, we need not to put the value of pi. We have to give the answer in terms of pi, multiple of. So the final answer is 72 pi. So this figure is bigger than this, so obviously this will have a larger area than 8 pi. So 72 pi is the area of this figure, which is similar to this one.